So me and Eric Larson were on Facebook yesterday, and we was talking about numbers. And there's this theory that Scott Flansburgh kind of pulled out of his bum. At least it seemed that way, called the theory of angles. You know, this theory where you got the number 1, comes from one angle, and then, you got the number 2 has 2 angles, number 3 had 3 angles. And originally, I thought that was a pretty smart idea. But I found some, videos on there, or some images on there showing that it might have been bogus. And, we don't really know how old numbers in that exact form really was, or which one indefinitely came first. But Eric Larson definitely has a pretty advanced theory on where the numbers came from that definitely isn't the status quo. So me and Eric were sitting on the computer, since we believed that, these were ancient letter forms that, definitely couldn't have been made in this way. We were scoffing at the idea and talking about, how stupid it was and how it would be more simple, if that was the goal, was angles, to use a simple zigzag pattern. Without further investigation, that actually makes a lot of sense. So basically, I was kind of humoring the idea of making a base 12 version of this number system anyway, just as sort of like a joke. And so I humored this theory, despite that the whole time, in my head, I knew that wasn't how they were made, quote unquote. And I saw this guy that's, basically showing this circle, and had this theory about, how the numbers, something about tearing a circle into 4 pieces or something and putting it back together as a square and then making this weird shape out of it. I was thinking, this guy is nuts. The squares and triangles have very little to do with our numbers. There is no indication, on these things that that even relates to 10 in any way, right? The triangle shape he talks about is 3-folded, and the 4 that he talks about is 4-folded. It could be in base 12 it might make sense, but I was thinking, this is the origin of the base 10 numerals. It makes no sense also because, this was sort of my superficial logic at the time. But if you actually go here where 5 is at, there's nothing at all that indicates that line shouldn't continue, as silly as a critique as that might be. So I tried doing it myself. So I did 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I thought it was time to do 10. Now in my head, this is what 10 probably would have looked like. Using my kind of logic, it would have kind of went like this. It would have had a really redundant shape, and it would have went across like this. But there's something in my head that told me, don't do it like that this time. Instead of doing this, and drawing this stupid redundant shape here, my head said, what I want you to do is I want you to put a stick in the middle. So I put a stick in the middle, and I made a 10 like I normally would, except it had a little extra of a wing on both sides. And then I realized something. This number right here can have 10 angles just as easy as all the other numbers have their corresponding angles. So you got 1, 2, 3, 4, 5, 6, 7, 8. That's 8 right there. And then 9 and 10, right? Because this is 6. This is 2, and this is 2, and we know 6 plus 4 equals 10. So I thought, would this work with 11? And so initially what I did is I tried doing it with 11. And sure enough, even though it was kind of cumbersome looking and it kind of looked a little ugly, I was able to do it with 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Kind of cumbersome, but I was able to do it. But then something occurred to me that I could clean this up a bit. And so what I did is I wanted to basically make it so that, see, I didn't like how this had a line here, but this didn't. I wanted it to be symmetrical. So what I did is this. I made the shape that I normally make, but I put a V shape here instead. And then when I came back around, I was able to do this. And once again, I counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then something else occurred to me. You know, a ruler is where base 12 idea came from. And these squares, these simple squares that are divided into, 4 sides, they give you no indication that this 5 shouldn't just go all the way up here. But then I thought to myself, that's also true for a lot of these other symbols. There's no way you could fit this symbol for 10 in this shape. It would end up looking ridiculous and wouldn't look much like, the 10 at all. It would look kind of like that. But then I got thinking, in ancient times, when this was made, these weren't divided into fourths. They weren't even divided into eighths. There are 16 units on here. 16. So my intuition was right when I was thinking, why in the world would you use fourfold geometry for a ruler-based system? And that's when I decided to make my own square inch diagram. And sure enough, each one of these numerals falls perfectly on this diagram with the square and everything. And you even have where the 8, if it went up higher, it would be just, this part would be just as big as this, but it stops. And that's exactly what we see in our modern day 8. And you'll notice here, I changed the symbol to fit more with this, and guess what? It still fucking works. Because you got 3 here, and then 4. 3 here, and 4. 5, 6. Right? You got 4 plus 4, which is 8. 9, 10, 11. Or 9 deck L. So, I got to the point where I began to realize, wow, this actually works. This theory works in base 12. And not only that, but as we all know, a ruler has 12 inches, each of which are subdivided into 16ths. So did I discover where our numbers came from? I can't say I did. But what I can say is that this is badass. And you want me to tell you something interesting about the heights of each one of these numbers that you would need to give it in order to get each one of these on here? A ruler has 16ths, right? But it also has eighths. Well, if each one of these is a length of 16, each one of these is a length of 16, and you go up 6, 1, 2, 3, 4, 5, 6, which is half of 12. Guess what you get? Guess what 6 times 16 is? Guess what that is? I'm pretty sure that's 96. And you know what that is? Eight times 12. Which is exactly how many eighths of an inch are on a ruler. So, this fits in perfectly with the concept of a ruler subdivided into 16 parts. As we know, the Egyptian pyramids were measured by the inch. They were measured by the inch, not by the centimeter. So this is pretty epic. This is pretty epic thought. You know, it certainly is a little bit more convenient than square root radii.